Okay, welcome back to the shop. This time we have a bit of a controversial topic. Oftentimes you see hobbyists say that you don't need fancy modern carbide endmills in your home shop. Of course, nobody really needs them, but they have their uses. And just to show you the difference between pretty old schoolish Clarkson FC3 cutter. These are these throwaway 3 flute high-speed steel end mills with the well-done shank that you can get up to 10 millimeters and are very cheap, and they still have their uses, and you can get them new also. But we will compare this to a modern 3 flute variable helix and variable pitch carbide end mill to a 4 flute HPC roughing end mill high speed steel and to a 4 flute HPC variable helix variable pitch carbide roughing end mill with without the serrations. So one thing that's often stated, that on our small hobby machines we can't run them at the speeds the manufacturer states, speeds and feeds, but I want to show you that they even work at our low range of speeds and feeds. I will calculate the correct speed and feed for this old school Clarkson FC3 cutter, and then we will run the carbide 3 flute, the roughing end mill and the 4 flute roughing end mill all with the same speed like this and give it a shot. Let's do the math and make some chips. Okay, we go for a cutting speed of 25 meters per minute. We have a diameter of 6 millimeters, so our speed will be, VC is 25 meters per minute times 1000 divided by pi multiplied by 6 millimeters. So VC is gives us a speed of 1300 RPM. And if you don't use a calculator, you can get out there these slide calculators for cutting speeds and feeds. Up here you select your cutting speed, in this case 25 meters per minute. Then you move over to your diameter of your cutter, and over here you can read your speed, and that's about 1300 RPM. And now for the feed. Fz is the chip load, and that's what every tooth of the cutter takes during one rotation of the material. And if you take a look in a chart for a 6 millimeter cutter doing slotting, the chip load is somewhere between 0.22002 millimeters up to 0.15 millimeters. We will stay well in the center of this and go for 7,000 millimeter of chip load per revolution and per teeth. So our feed is VC, or rotational speed, multiplied by the count of the teeth multiplied by the chip load, and that's 1300 RPM multiplied by these Clarkson cutters have 3 flutes, multiplied by 3 multiplied by 0.07 millimeters, and that gives us a feed of 27 millimeters per minute, or we will go up to 30 millimeters per minute. That's our feed. At first glance, 30 millimeters looks very slow on the feed, but we're going to do heavy roughing, and therefore you have to keep the chip load a bit smaller, because otherwise you will get into problems. And we will run the same parameters with all 4 cutters. But with the 4 flute ones, with the 2 4 flute endmills, we have to increase our feed because we have 4 flutes to keep up the chip load. With a 4 flute, we will run it at 1300 multiplied by 4 flutes multiplied by 7000 millimeters chip load. We're running at call this F4 is 36 millimeters per minute. Okay, that was a lot of math. You're all bored right now and want to see chips. So let's go over to a machine and set it up. This is a piece of 10 millimeter carbon steel. For the European users, it's C45. And we'll clamp it down using a standard Weldon end mill holder. That's the type with the set screw that engages the flat in the end mill. They are for roughing, they are very fine. We will begin with the high-speed steel Clarkson FC3 cutter. Okay, we have our 1300 RPM touched off on the surface of my test piece. The feed and speeds are set, and now we're going to take a first pass with a depth of cut of 1 millimeter. We're running all these tests dry, without cutting oil or lubricant, just to keep the testing circumstances the same. Okay, no problem there. That was to expect. 1 millimeter depth of cut for a 6 millimeter end mill is really not that much. Now we're going for a cut of 2 millimeters. Okay, that one was also absolutely no problem. Now we go for a depth of cut of 4 millimeters. That also really not a problem. Now we go for 6 millimeters. Next cut will be 8 millimeters with the 6 millimeter 3 flute FC3 cutter. interesting. Up to 6 millimeters with the given feed and speed, there was absolutely no problem. The end mill took full slotting cut of 6 millimeters with a speed of 1300 RPM and a feed of 30 millimeters per minute in this carbon steel without any problem. It dropped out nice, very nice chips. The end mill didn't drop and everything was fine. The 8 millimeter deep cut, that was too much for this end mill. It started to vibrate and to chatter slightly. So 1 times the diameter for this small end mill on depth of cut is not too bad. So let's see how the modern carbide end mills and the roughing end mills compare to this. Next one in my test series is this variable pitch 3 flute carbide end mill that's already used and reground by me. No problem there. Now we go for a depth of cut of 4 millimeters. And 6 millimeters depth of cut. Okay, and for the next step, this is 8 millimeter depth of cut. Now it takes a 10 millimeter deep cut in this material and the cut stays absolutely smooth and silent. It's just hogging away material. So this test produced a lot of chips. The modern carbide end mill took the 10 millimeter cuts without a problem. It produced nice heavy chips. And the cut went really very smooth. So I think that's a clear win for the modern end mill. Okay, that was not surprising, but just to show you the difference, and that even on the lowest end of speed and feed, the modern end mill outperforms the old school cutter. For the roughing end mill, I picked out a thicker piece of material because the 3 flute carbide end mill already maxed out the thickness of material. This time we can go way deeper because this is the same material, the low carbon steel C45 with 0.45% of carbon. Now we go with 40 millimeter deep cut with the roughing end mill. This is a used end mill and I don't mind breaking it, so let's see if this end mill takes this cut. Okay, you see the end mill took this cut without much hassle, and one thing to notice, with cut that deep, the getting away the chips starts to be a problem. If you don't want to use coolant, you would need to use an air nozzle to blow away the chips out of the slot you cut, to prevent recutting the chips. Recutting chips with an end mill is one of the worst things you can do. It ruins the cutting edges pretty fast. So okay, this roughing end mill did what it's supposed to do. It made a huge mass of chips and it took the 14 millimeter deep cut without any problems. This is our last milling cutter. This is a 4 flute HPC roughing end mill with no serration in the cutting edges, though this can double as a finishing end mill. With this one we will do something different. We will take a 6mm deep cut on our feet of 36mm, see how it goes, then we will step over, again 6mm deep cut, and we will increase our feet, and then we will look how it goes. As this is a real roughing end mill, carbide end mill, we should get pretty much performance out of this one, so let's see. Oh, 50 millimeters per minute of feet. That went fine. Now we go for 70 millimeters per minute. No problem there. We'll ramp up again to 90 millimeters per minute. Now, the chips get pretty heavy and they start to get a very little bit of color, so this end mill is not really maxed out. Let's go up to 120 millimeters per minute. We have a nice set of light brown chips, and I don't want to go any further. I have no need to really break this end mill just for fun. Okay, we're back on the bench, and we made a lot of chips, a huge mess, and cut down some material, so this was a good day, and I think we have some results. The FC3 cutter, the Clarkson cutter, is not that bad. It could take a 6mm deep full slotting cut at 1300 RPM and 30 millimeters per minute without much problems, but the modern end mills outperformed it hugely. Even this cheap 3-flute carbide end mill with the variable pitch and helix and stuff like that could take a 10mm cut at the same feet and speed without problem. The roughing end mill is another beast. With the same speed and feet, it went down 14mm into this material and it was still running very smooth, and this is what these roughing end mills are made for. And then the modern roughing end mill carbide 4-flute, also variable pitch. These are awesome. I just ran them down 6mm, but I increased the feet because these cutters are high feet cutters, and even on my home shop machine I could run them at 120mm with 6mm deep cut in carbon steel, and I got nice light brown chips. Could run the cut dry. I hate using lubricant on the milling machine. I try to do most of my milling dry, so that's one of the reasons why I go for carbide. When dry machining, they last a long time, and you can remove quite a lot of material. We started at 36mm per minute of feet and ramped it up to 120mm per minute. That is pretty fast when you're taking such a deep cut, and you produce a pretty good chip volume in a short time period. 1300 RPM, 4mm, 120mm per feet, and that's only a chip load of thousands of millimeters, so I think that's not the limit of this end mill. I would have to look it up, but I'm sure this can take quite a bit more on the chip load, and of course the cutting speed itself, the rotational speed. We're very much on the safe side with our 25 meters per minute. You could easily multiply that by 4. 100 meters per minute for a carbide end mill in steel is not really a problem. So I hope I could give you a short insight on difference in the cutting geometry and show you that the modern geometry on these end mills is not only on high performance machines very useful, but also on our home shop machines. So thank you for watching. I have the suspicious feeling that I have to do a second video on this topic after the comments, so thank you for watching.